Here we are looking at the formation of the bonding orbitals of hydrogen, molecular hydrogen, which is H2. Here on the far left, we have the orbital of the atom, so it's an atomic orbital of one atom. On the other side, the far right, we have the atomic orbital of another hydrogen. So the far left-hand side atomic orbital and the far right-hand side atomic orbital are coming together to form those molecular orbitals in the middle. So you can see we have 1, 2 atomic orbitals forming 1, 2 molecular orbitals. So the same number of atomic orbitals we have results in the same number of molecular orbitals. So when these two orbitals come together in phase, we are forming the sigma bonding molecular orbital, and when they come together out of phase, we are forming the sigma antibonding molecular orbitals. So your s orbitals, when they come together, they always form sigma molecular orbitals. So let's play the animation. Here they're coming in phase, bonding orbital. Here they are going out of phase, antibonding orbital. Let's look at that again. In phase, bonding orbital, out of phase, antibonding orbital. So you can look at the color. So if it's the same color, it's in phase, bonding orbital. If they are different colors, out of phase, antibonding orbital. Okay, let's stop the animation. So what I would like you to also look at is where's electron density. So an orbital just tells you where you can find an electron. Where's the highest probability of finding an electron? So that's why we also talk about electron density. So when you look at the two atoms that are bonded, you see there's some electron density in between. So those electron density are keeping those two hydrogen atoms together, and therefore when we are having a bonding orbital, it increases the bond order, and it makes that bond more stable. Now if you look at the antibonding orbital, you see there's no electron density between the two hydrogens. So if you've got electrons in the antibonding orbital, it decreases your bond order and it destabilizes the bond.
This is the bonding molecular orbital. It forms when the two atomic orbitals combine in phase. If there is electrons in this orbital, it increases the bond order and makes the molecule more stable. In the case of hydrogen, there is 2 electrons in this orbital. P is the anti-bonding orbital that forms when the two molecular orbitals combine out of phase. There is no electron density between the two atoms. If an electron is in this orbital, it decreases the bond order and destabilizes the bond order. In the case of hydrogen, this orbital is empty. The red lines are connecting the atomic orbitals with the bonding molecular orbitals. These lines are important since they show the 2s atomic orbital combines to for the molecular orbital. In this particular example, the situation is simple but more complex molecules. These lines become very important to understand which atomic orbitals combine to form the molecular orbitals. These lines show that the 1s atomic orbitals combine to form the anti-bonding orbitals.